2-4, complex numbers. So we are still talking about quadratic functions, but we're putting a little pause on the normal that we have been talking about, and instead we're going to talk about some complex numbers, which means that there are such things as imaginary numbers. So far in your your math career, you probably have not seen an imaginary number, but they do exist. The most common use of them is in electrician. So in electricity, if you become an electrician, they use complex numbers. It is not super common, but it does fall nicely into our quadratics. So that's what we're going to talk about today. All right, so remember to have a squared. It is a number times itself. However, I cannot multiply a number by itself and get a negative number. Therefore, that's where imaginary comes into play. So anytime I make my eye, you'll see a little curve at the bottom so that we don't think that it's a 1 with a random dot hanging out. We know that it's an eye. And it always equals the square root of -1. Okay. We can also note that I squared would equal -1, because squaring something would get rid of the square root. So how would I use that to solve this example on page 84 in your workbook? Right now I have x squared. To get this x by itself, I'm going to take the square root of both sides. So maybe you make a note over here, the inverse of squared is square root. So your teacher may ask you, what undoes addition? Subtraction. What is the inverse of multiplication? Division. So that's what we're asking here. So the inverse of squaring something is to square root it. So if I had some number squared with a square root, it's just that number. Okay. When I'm solving an equation, I could have the positive or the negative of that number. Okay. So then I have the positive or negative of -5. Well, hopefully you can agree with me that 5 times -1 is the same thing as -5. That means I could separate these. Okay, my multiplication rule says that I can separate them into their own square roots. And if you recall what I just wrote over here on the left-hand side, the square root of -1 is equal to the letter I. Okay. Most of the time, it is more common to put the I on the outside, because when it's in the very back like this, it's hard to tell, is it under the square root? Is it not under the square root? We're not sure. So a lot of times we just like to put the I in front of the square root. Okay. So let me do a quick recap for those of you that is like, what just happened? The short version of that is anytime you see a negative under the square root, you need to bring it to the front as I. So that is equal to I square root of 5. Okay? So taking that means this would be I square root of 72. Right? All right. Now, The difference in this is it can be simplified. 5 is prime. It cannot be simplified anymore. But 72 can be simplified. So I want to think about what is the highest perfect square that could be used. So a perfect square is going to be 1, 4, 9, 16, 25, 36, 49. So it's actually going to be 36 times 2 will give me 72. And then I think, what's the square root of 36? Well, that is 6. So I have 6i square root of 2. Now, I also know that I probably just blew your mind if math is not your jam. So if memorizing all of your math facts did not come easy to you, there is a calculator way to do it. Now, that being said, this is a time where I'm going to suggest a like graphing calculator that you were used to using at school back when we went to school. So I like the Calculate 84 app. Okay. You do not have to sign up. You can skip. It just doesn't save whatever you did. That's cool. And here's how I can use my calculator to set this up for me. I go to y equals. Whatever that number was under the radical, I type it in. So in this case, it was 72. Ignore the fact that it was positive or negative. I don't care. I want to know how to simplify the actual number itself, not whether it was positive or negative or real or imaginary. Okay? And I'm going to divide that by x squared in order to get what I want. You will always divide by x squared. Then I'm going to hit second graph. Don't worry, we're going to go back in a moment and write down these steps in our notes. Second graph. And then you want to go all the way down as low as you can. Now, once you notice my y values, once your y values are less than 1, you have gone too far. Okay? So I do not want to go past 8. I want to find where the x value is a nice number and the y value is a nice number. So notice that that is at 6, 2. Side note, if you are on a school-issued Chromebook, you should have access to a graphing calculator app already on your Chromebook that should look like the ones we use in school. All right, notice that my last numbers that are nice are 6 and 2. Okay, also notice that I do have 3 and 8. I don't want 3 and 8. I want to go as far down as I can before it turns into all decimals. So that is 6 and 2. The x value is going to be outside the square root. The y value is going to be inside the square root. Well, that should make sense if you look at your answer here. 6 is on the outside. 2 is on the inside. Remember, the reason I have the I there is because there was a negative under the square root. Okay, so that's how I would simplify a radical. Okay. Adding and subtracting comes next. You would add and subtract this just like you would combine like terms. Same idea. So negative 4 plus negative 2 is negative 6. 6i plus negative 9i is negative 3i. Well, that was easy. Subtraction requires one extra step, but it's just as easy. I need to distribute that negative sign. So a negative times negative made my 4 positive. A negative times a positive made my I negative. Now combine like terms. 3 plus 4 is 7. Negative 2i minus I is negative 3i. Fun fact. Oh, let's do one thing calculator, and then we're going to take an intermission to write down our calculator steps for the things that we did. All right. My calculator, if I go back to the main screen, so I hit second mode to quit, notice your decimal point is actually an I. So I can type 3 plus 6I minus 7 plus 4I. I totally made that up. That is not the example we just did. I don't remember what the example was that we just did. But when I do that, it will give me my answer, both the real and the imaginary part. So let's go back and write some steps there. That was second decimal point on a TI will give me I. For if I want to simplify those type of problems. Let's go back up here and write down our steps that I told you we were going to write down and I forgot. So we went to y equals, and then we put, actually, you know what? I'm actually going to label this so that I remember. All right, calculator steps. We did y equals, and in y equals, we put the number divided by x squared. Then we pressed second graph to look at the table, and we went all the way down to the last integer, so that just means number, in the y column. And then to write your answer, you write it as x square root y. Okay. All right, so calculator steps. Let's look at multiplying. Multiplying by hand is a little harder because you might get something like I times I, which is I squared. Remember we said I squared equals -1. Okay. So hold on with me because I am going to do it by hand, but then I'm going to show you in the calculator that we do get the same answer. To multiply 2/5 by 10, I do 2 times 10 is 20. Divided by 5 is 4. So that's 4i. Then I do 2 times 5 is 10. 5 times 2 is 10. 10 divided by 10 is 1, and it's negative because a positive times negative is negative. And then I times I is I squared. So then that means I have 4i minus 1 times -1 because I squared equals -1. So I have 4i plus 1. The proper way to write that is 1 plus 4i. Calculator to do it for me because that blew my mind and I hate fractions. I'm sure some of you guys are thinking that. Did I already mess it up? Hold on. All right, there we go. Look at that, 1 plus 4i, which is what we just got. Okay. Same thing for the next one. If you want to kind of fast forward a few seconds, you can just type it in your calculator to get the answer. Or you can do the box method to multiply. So I'm going to put 1/2 here, 2i here. I'm going to put 1/2 here and -2i here. 1/2 and 1/2 is 1/4. 1/2 of 2 is 1. 1/2 of -2 is -1. And then negative 2i times negative 2i would be negative 4i squared, which would equal negative 4 times negative 1, which is actually 4. Combine your like terms. 4 plus a fourth is 5 fourths. I minus I is 0, so my answer is just 5 fourths. Calculator to check that answer. Oh no, it gave me a decimal. But if I hit math, enter, enter, I get 17 fourths. And this is where I should stop and redo my math because I still got the right answer, but not really. So fractions are apparently not my friend at the moment, but I'm not recording this whole video over. So if we were in class, I would make that mistake and you would tell me. So that's what I'm doing right now. 4 plus 1/4 is 4 1/4, which is 4 and 2.25, if you think about it like quarters. If I want to convert that to an improper fraction, 4 times 4 is 16, plus 1 is 17 fourths. So this is why we like our calculator, because even your math teacher has bad math days. And we're going to look at one more type, and it is the hardest to do just because we got to make sure we put it at the right spot, okay? We can use our calculator for it as well. I will show you the long way. It's not my favorite, but it happens. If you notice here, when I had two different signs, it gave me a real number, right? So if I multiply this by something with the opposite sign, it's going to give me a real number. But if I do something to the bottom of an expression, I must also do the same thing to the top to keep it equal. Okay, so 80 times 2 would give me 160. 80 times 6i would give me 480i. And then here I would get 2 minus 36i squared. Okay, so 160 plus 480i all over 38. I can reduce that to get a final answer, but I could also just use my calculator to begin with. Now, to use my calculator to begin with, I'm going to do 80 divided by 2 minus 6i. Notice the parentheses. They are a must. In fact, I'm going to highlight those so that you remember. You must have the parentheses or you will not get the right answer. So let's go back and look. 80 divided by 2 minus 6i. Uh-oh. That was just supposed to be a parenthesis, not the tangent. Doing all kinds of things I shouldn't be. All right. Then when I hit enter, I get the answer 4 plus 12i. Whoops, I need to go back to my pen. Which is my final answer. And I have made a mistake in my work over here, so let's go back and look. Or did I make a mistake here? I made the mistake here. Notice my original problem, so I didn't do my math wrong. All right, I figured it out, y'all. What is 2 times 2? 2 times 2 is 4, which means that this should be 40, not 38. Which then, yes, I would get 4 plus 12i. Another reason I strongly encourage the Calculate 84 app or the Chromebook graphing calculator for this particular problem. Okay, same here. I would put this in the calculator. If you're going to put that in the calculator, 4 minus 3i divided by -1 plus 2i. So switch back over to my calculator. Make sure to use your parentheses. So everything on the top has to be grouped in parentheses, divided by everything on the bottom grouped in parentheses. Okay. If you were ever to get a crazy decimal, because I'm pretty sure it happens, and they want your answer in fraction form, all you would have to hit is math, enter, enter, to turn it into a fraction, okay? So what would an example of that be? This is a made-up example. I'm hoping it gives me decimals. Okay, see, it gave me decimals. Craziness. Like, I don't want to write all that down. Hit math, enter, enter, and that one doesn't work. Of course it doesn't. Let's try another one. Okay. That should work for those of you on a Chromebook. It looks like it does not work in the Calculate 84 app. So, FYI. You should still be able to solve your problems without that. Just know that that is a possibility. -2 minus I is the answer. Okay. All right, so last but not least, if I solve an equation, this goes right back to, I'm going to do these pretty quick. These go right back to example 1. All I would do is subtract 49. Take the square roots. Well, the square root of 49 is 7, but when there's a negative under the square root, that means it could be positive or negative. So plus or minus 7i. In the second one, I would subtract 25. Divide by 9. That looks complicated, but lucky for us, those are both perfect squares, so it's actually not bad at all. The square root of 25 is 5. The square root of 9 is 3. And the negative under the square root means it is I. Okay, so we have now completed 5 problems. This video ended up longer than I anticipated. I am sorry. Submit your notes, submit your target, and you have